I'm going to give you an overview of sepsis research at the laboratory surgical research. Before I start, I would say a few words about our support and mainly the people in our lab. Our sepsis research program has been supported by several NIH grants, mainly by NIGMS for more than a decade. And recently, we were supported by the National Institute on Aging. The work I'm going to present was done by all those people. I'm here just represent the whole lab to give you some overview about the recent work. And today I'm going to describe several areas regarding a couple areas, mainly was done by Dr. Wu and others. He has been a leader in that area. And I'm going to describe the phagocytosis and apoptosis, which has been done by Michael Mixa, among others. Sepsis is a major problem. There are more than 750,000 people suffer from this disease. More than 28% of those patients die each year. Sepsis is the 13th leading cause of death overall in this country. Sepsis has significant economic impact to our life. This data is at least 5 years old. As you can see, 5 years ago, sepsis cost this nation $16 billion. Now the number can go as high as $25 billion. Unfortunately, we don't have much specific anti-sepsis drugs. So far, only one drug called activated protein C, which has been approved by FDA, can be considered as a specific anti-sepsis drug. So based on this limited choice for this disease condition, it is very important to develop new drugs for sepsis. In the next 18 to 20 minutes, I'm going to give you some overview about 3 ongoing projects. This lab, we have been very interested in peptide protein-based therapeutics. I'm going to talk about a peptide called adrenomyelin AM and its binding protein, adrenomyelin binding protein 1, AMBP1, and the cardiovascular response. And secondly, I'm going to talk to you about a relatively new peptide called ghrelin. In this area, we are going to touch aging and inflammation. And finally, we are going to discuss apoptotic cell clearance and a relatively new protein in this area called MFGE8. Adrenomyelin is a 52 amino acid peptide, which is a middle-sized peptide. The major biologic effect of this peptide is to work on the blood vessels. And basically what it does is to dilate blood vessels. As you can imagine, if you give too much adrenomyelin, you can cause hypotension. And if the dosage is extremely high, that can kill an animal. However, our focus is use very low dose of adrenomyelin to treat septic animals.